For more videos, visit forthesakeofeducation.com. Alright guys, let's do these two problems where a force F acts perpendicular to the inclined plane. Find the moment of F about A and find the moment that F produces about B. So let's find all the points involved. A sits at 0i plus 0j plus 3k. B sits at 3 in the I plus 0 in the j plus 0 in the k. C sits at 0 in the I plus 4 in the j plus 0 in the k. So the first thing we need to do is find the vectors AC and BC. So AC and BC. AC is C minus A, and it comes out to be 0 in the I plus 4 in the j minus 3 in the k, and this is C minus B, which is negative 3 in the I plus 4 in the j plus 0 in the k. So what you need to do is you need to find the Cartesian vector form of F, and they tell you that F is perpendicular to both this vector BC and this vector AB. Now you know that to find a vector that is perpendicular to two vectors, all you got to do is do the cross product. The cross product is always perpendicular to both vectors that create the cross product. So we're gonna do the cross product in order to be able to find the Cartesian vector form of F. So the cross product between AC cross BC, AC will be this vector and this vector. You gotta use the right hand rule. It has to be AC cross BC. If you do BC cross AC, then it's gonna give you the vector going down, and that will be wrong. So make sure this is AC BC, and you use the right hand rule, so it will point in the right direction. When you do this cross product, you get your I, J, K. This is 0, 4, negative 3, and this is negative 3, 4, and 0. So this is I. Repeat the first, second column. 0, 4, negative 3, 4. You do your positive diagonals. I times 4 times 0, 0. J times negative 3 times negative 3 is positive 9j. K times 0 times 4 is 0k. Negative diagonals, these are the positive. Negative diagonals, negative 3 times 4 times 12 is positive 12k. Negative 4 times negative 3 times I is positive 12i. And 0 times 0 times j is 0. So this is 12 in the I plus 9 in the j plus 12 in the k. Now this is a vector that is perpendicular to this plane. These two vectors BC and AC. So now that you have this vector, what we're trying to do is we're trying to multiply F by a unit vector going in its direction in order to find its Cartesian vector form. Now this vector goes from here all the way to here, let's say, more or less. Let's call this point D. So the vector CD is given by this cross product, but we're trying to find the unit vector CD. So if CD is equal to 12i plus 9j plus 12k, we find the magnitude of this vector CD by doing the square root of x squared plus y squared plus c squared. When you plug in these three values into this formula, you're gonna get that it has a magnitude of 19.2. a univector CD is given by dividing the vector CD by its magnitude. So when you divide these three values by this 19.2, you get the univector CD, which comes out to be 0.625 in the I, plus 0.469 in the J, plus 0.625 in the K. Now, F is given by its magnitude, which is given at 400 newtons right here, times the univector CD. So multiplying 400 times these three values gives you the Cartesian vector form of F, which is 250 in the I, plus 188 in the J, plus 250 in the K. So they want you to find the moment that F produces about A. The moment that F produces about A is given by vector A from A to C cross Cartesian vector form of a force. You get your matrix I, J, and K. Here you get AC, which we found at the beginning right here, which is 0, 4, and -3. And at the bottom you get the Cartesian vector form of the force, which is 250, 188, and 250. Redraw first, second column, 0, 4, 250, 188, two positive diagonals, positive, positive, positive. You get that the positive diagonals are I times 4 times 250 is 1000 in the I. J times -3 times 250 is -750 in the J. K times 0 times 188 is 0 in the K. Negative diagonals. Negative 250 times 4 times 1000 is -1000 in the K. Negative 188 times -3 times I is positive 564. And negative 250 times 0 times J is 0J. This is in the I. When you add them together, you get that the moment that the force creates about A is 1564 in the I, minus 750 in the J, minus 1000 in the K. The force is in newtons, distances are in meters, so it's Newton meters. So this is for the first part. For the second part, the moment that the force creates about B is given by the cross product from B to C cross F. BC we found at the beginning, right here. Right here we found BC. So we draw our matrix I, J, and K. BC is -3, 4, and 0. And the Cartesian vector form of the force we found is 250, 188, 250. You redraw your first and second column. -3, 4, 250, 188. We do positive diagonals. Positive, positive, positive. Positive diagonals come out to be 1000 in the I, plus 0 in the J, minus 564 in the K. Then we do our negative diagonals. Negative, negative, negative. They come out to be minus 1000 in the K, plus 0I, plus 750J. And when you add them together, you get 1000 in the I, plus 750 in the J, minus 1564 in the K. Again, this is Newton meters. So final answer for the second part. Please comment below if you want me to do any problems, and I'll be happy to help. Thank you.